Hello, this is INE Foundation Lab 2, section 4.4, OSPF. Okay, before I conclude this section, let's review what OSPF is. Okay, first let's review OSPF LSA types, then I will explain OSPF Stub areas. Okay, first OSPF LSA. This is LSA 1, type 1, water LSA. Water LSA stay within area, and we can find direct connector links of routers in this LSA. If we do show output route, we will see all entries for LSA type 1. Second LSA is LSA type 2, network LSA. It stays within area and is being generated by DR in multi-access network. In the network type we have DR and BDR, it will generated by DR. And we will see all entries in show IP route. Then we have LSA type 3. This is if we have multiple areas like this scenario. We'll clear this. If we have multiple areas, we will have ABR between these areas. This is OSPF 0, 2, 51. LSA type 3 flat into all other areas in our OSPF network and is being generated by ABR. And we will see OIA entries for this type 3 summary LSA. Show IP with OSPF. Then we have LSA type 4 and type 5. Okay, type 4 and type 5 are close to each other. They work together in real world. LSA type 4 and type 5 they work together. Okay, let me explain what are the LSA type 4 and 5. Excuse me. Okay, if we add another routing protocol into our network, for example RIP, then we redistribute this prefix into OSPF. And if we redistribute this, if we redistribute this prefix 555/24 into our OSPF network, redistribute, then this R1 will become ASBR. And other routers, for example, other ABR in our OSPF network, for example R2 and R3 and R4, we use type 4 LSA to inform other areas or other routers in the our OSPF network where our ASPR is located. For example, R2 will advertise summary ASPR LSA. We'll tell other routers in our network that R1 is our ASPR. will tell other OSPF network where our OSPF is located. This is the job of LSA type 4 to inform other network where our ASPR is located, and is being generated by ABR. LSA type 4 is being generated by ABR, but LSA type 5 is being generated by R1 or ASPR, not ABR. R1 here will generate LSA type 5, flood into all other OSPF network and being generated by ASPR. Excuse me. And LSA type 4 is being generated by ABR and will flood into our OSPF network. For LSA type 5, that is ASPR, we will have or E1 or E2 entities in our product. Okay, then we have LSA type 7. I will explain this in stub areas later. LSA type 7, this is not a stub area. This LSA type 7 is when we want to have ASPR in our stop network. What does it mean? For example, if let me explain this. If I make this area NSSA, this is one kind of stub area, and in stub in stub areas we can't have ASPR, but if we create this area as NSSA, then this NSSA will allow us to have ASPR. This R1 will become our ASPR. Then, because type 5 LSA is not allowed in NSSA, this ASPR will generate type 7 LSA. And other ABR in our OSPF network will translate our type 7 into type 5 LSA. This is flooded into only NSS area. This is type 7 and it's being generated by ASPR because we want to have ASPR in stub area. And because type 5 is not allowed in NSSA, then it will create the type 7 LSA and being translated by next ABR daughters from 7 to 5. This ABR will translate 7 into 5. We will have N1 and N2 entities in short product OSPF. Okay, now let me experience this area. We will better understand what we are talking about. Okay, as I said before, we have a stub area, then total stub area, NSSA, and total NSSA. Okay, if we create area stub, we will not have, we are not allowed to have type 5 external area, external LSA. This is LSA. And in the stub area, we can't have ASPR. Okay, if I create this area as stub, we can't redistribute this prefix into OSPF. It means that no redistribution is allowed. We can't redistribute any prefix into our OSPF. But if we want to have a stub area, and we also want to have redistribution, we can create an SSA. An SSA is not type 5 external. This is LSA. No type 5 external LSA, but we can have ASPR and we can redistribute prefix into OSPF. This is the feature of an SSA. It means that we can redistribute this prep into OSPF. What is total stop? Total stop is no type 3 summer LSA, no type 5 external LSA, and no ASPR is allowed. We can't have all this in this total stop. But what if we want to have ASPR? We can create totally NSSA. This means that no type 3 summer LSA, no type 5 external LSA, but we can have ASPR. ASPR is allowed in totally NSSA. It means that we can redistribute prefix into OSPF. Okay, and there should be at least one able in area. All routers in the stub area have to configure as stub router. All router in the stub area have to configure as stub router, and there is no ASPR within stub or total stub, as I explained before. In total stub and stub, we can't have ASPR. This means that we can redistribute prefix into OSPF. The pipeline area cannot become a stub or totally stub area. Okay, this was our OSPF, part of our OSPF concept. This concept is enough to configure this section. Okay, now let's configure this section. Configure R3 and 10, R3 and R10 into OSPF area 51. We have between this 3 and 10 this interface Ethernet 1.103. Okay, let's open this section. I will use interface level configuration here. Config T do short interface brief. We have 103. This is this interface. I will IP OSPF 1 area 51. Okay, now let's configure other side of our router. Show IP interface brief. This is config T. Interface this one. and simply use IP OSPF 1 area 51. Okay, I can verify, but do show IP OSPF interface brief. I have configured this on this interface. So area 51 and this one. Do show IP or oops. This is the previous section, and this is this one. Okay, now the area 51 ABR should filter type T and type 5 LSA from entering the area. Excuse me. The area 51 ABR should filter type T and 5 into the area. Oops. Where is our topology? Okay, RT is ABR. The area 51 ABR should filter type T and type 5 LSA into the area. T should block type T and type 5. Okay, we have two options here. One is totally stub area and the other one is totally NSSA. These two options will block type T and type 5 LSA. And because totally NSSA will allow us to redistribute into OSPF, I will use this totally NSSA. Okay, enable totally NSSA on R3 and NSSA on R10 on for area 51. Okay, let's configure. If we do show run pipe section with the OSPF, or about the OSPF 1, and create NSS. This RT is ABR. I have to do totally NSSA. Just simply type area 51, then NSSA, then we have no summary. It will make this area as totally NSSA. It will block both type T and type 5. And on R10 I will use OSPF 1 area 51 NSSA. Okay, I can let's verify. If I do show IP root OSPF, on R10, this is R10. So from this via this interface, this is ORA and ON2. This is type 7 entities. And if I do show IP OSPF database, I will have type 5 and type 3, and type 5 is not allowed. I only have type 7 LSA. Type 7 LSA, and I don't have type 3 and type 5 because this is totally unnecessary. I can redistribute because this is redistributed into OSPF. If I do show run type section, so this is redistributed. RT is redistributed its loop back into OSPF. Then I see this redistributed prefix into our OSPF database because it is totally unnecessary, and it is ASBR. It is already distributed. Okay, this is this part. The configure R10 to advertise its loopback 0 and this VLAN 104 networks into OSPF. Okay, let's go into R10. Do show IP interface brief. It means this interface should be this interface. I have to advertise this interface and loop back 0 into OSPF. Okay, I will simply use interface level configuration. Go to interface, IP OSPF 1 area 51. And interface loopback 0 and IP OSPF this one. Okay. Excuse me. Now R3 should see no this one. R3 should install two equal cost paths. This is equal cost this MP. Two equal cost path into R3 networks via this Ethernet 101 point this is gigawatt in the topology of Ethernet and dialer 103. Okay, on R3 this is let's see topology. Oops. Between R3 and R10 we have this Ethernet and we have also point-to-point over Ethernet interfaces. Okay, now let me first advertise this PPPoE server and client into interface PPPoE and client interface into OSPF. R10 is server. Let's advertise this interface with virtual template 103. And T is client. This should be the interface diagram. Okay, now let's see what cost this interface is using for OSPF to show IP OSPF interface. This one. Well, it uses cost of 10. Let's change interface cost interface dialer. Where is our dialer? It's just interface. Let's press MTU 1492 and IP OSPF cost to equal cost. This is the same cost as this Ethernet. Ethernet is using 10. I will set this cost into 10 either. Okay, now let's verify. Show IP root 10 10 10 10 10. This is the 32. Okay, I have two blocks, sorting description blocks. This is one via dialect 103 and the other is via Ethernet. This one. We can verify by show IP self either. Show IP self. This command and detail. I have two next up for this suit. One is for this one and the other is for this one. Okay, R3 should see R10 loopback 0 as this slash 32. This is seeing this as slash 32. We can see R3 is seeing R10 loopback as 32. This is no problem. But the rest of the OSPF domain should see it as slash 24. Okay, now let's see topology. Let's check on R5. Show IP root 10 10 10 10. Okay, R5 is seeing R10 loopbacks of slash 32. But it should see as slash 24. Yeah, okay, we can achieve this goal by summarizing this excuse me, by summarizing this network into other area of the network simply by using area range command. Okay, on R3 I will summarize this into a slash 24. So let's go to config T. So to OSPF 1. I will say area 51 range should be 10 10 10 0. The max subnet mask should be 255.255.255.0, not 255. But it's just slash 24 subnet mask. I'll tell you now summarize this network into a slash 24 instead of 32. Okay, RT is seeing this root as 32. Now R5 should see it as 24. Okay, now we have slash 24 instead of 32 because on our T I said area 51 range is summarized into this network. Okay, now we reach last section. A Comcast subsequent failure detection over this link area 51 link. Okay, we will use BFT here. So we have to BFT. Okay, let's come for BFT. Subsequent failure. Okay, also the OSPF 1, BFT, all interfaces. And on the interface level, we use BFT interval 0, now 0 to 50, and multiplier 3. Same as on R10. And we can verify by Show be obtainable details. This is up. And this is registered protocols, OSPF and SEP. Okay, this was section 4.4 configuration. I hope you have enjoyed this video and thank you for viewing.